Welcome viewers and students to another session of challenging problems, and this was one of the questions my students asked, and this is based on trigonometry. Now the question is very big but the working is very simple, and this is a live application question which happens in daily life, and it is an authentic situation. So we are looking at problems where maths can be applied at authentic situations. All right. So here, this is a question. Planes that fly at high speeds and low elevations have radar systems that can determine the range of an obstacle and the angle of elevation to the top of the obstacle. So basically you see this is the aeroplane. Let me mark as A. This is the horizontal distance and this is the tower you will see here. All right. And this is the hypotenuse of this particular right angle triangle and this angle of elevation. Okay, so let's see the radar of a plane flying at an altitude of 20,000. So basically if I look at this altitude is nothing but 20,000. So this particular whatever he has marked is actually 20,000. The balance of the distance is 20,000. Is that okay? From the ground level. So I need to find what is, let's say this distance is h. My question is the radar of a plane flying at a height of 20,000 detects a tower. So it detects the top of the tower that is 25,000 feet away. So that is this distance, the hypotenuse distance with an angle of elevation of 1 degree. How many feet must the plane rise? Okay, so how high it has to rise so that it can safely cross the tip of the tower. So this is basically nothing but a right angle triangle. So 1 degree, this is the opposite side. I want h, and this is the hypotenuse, right? Now, basically the relation or the trigonometric ratio which relates opposite to hypotenuse is sine. So I'm just going to use sine 1 degree which is equal to opposite side which is denoted by h and the hypotenuse is 25,000. Alright. Now if I cross multiply I will get h is equal to 25,000 multiplied by sine 1. So if I use the calculator, I am going to get this to be equal to 436.3 feet, correct to 1 decimal place. Is that okay? So now the plane has to rise. So the plane has to rise 20,000, which is the original distance it's flying, plus 436.3 feet, which is 20,436.3 feet. All right. So once the plane rises to the feet, it would safely cross the tower. But in actual, you had to go a little bit higher. All right. So let's see what's the next question. Planes cannot come closer than 1,000 feet vertically to any object. So basically this is the thing. So the safe distance according to regulation, it cannot come 1,000 feet vertically. So this is very important. You need to note that. So at what altitude must the plane fly in order to pass over the tower? So basically initially it is 20,436.3 feet. That is just the correct height of the tower, but to be safe you need to add another 1,000 feet, right? So that becomes 21,436.3 feet. All right. So the plane has to fly at an altitude of 21,000, okay, 21,436.3 feet. Okay, so this is the safe altitude. Right? So I hope this was clear, and it's basically very simple, but sometimes students get overwhelmed because of the amount of information and data, and to extract the data correctly is very, very important. All right, so stay tuned for another session, and please do write your comments, and if you have any other questions, interesting questions which you would like to be addressed, I would do so. And please do not forget to like and subscribe. Thank you.